Good day, Doctor. I'm Vinoshni Pubalan. The mini project title we have chosen for our material selection is Hydrogen Based Power Station in Malaysia. So, first of all, I would like to explain why hydrogen is needed for Malaysia. As we all know, 95% of Malaysia's energy still comes from the fossil fuels, where hydrogen offers a clean and low carbon alternative that can significantly reduces the emissions. Currently, Malaysia is targeting a net zero emissions by 2050, and hydrogen plays a key role in this goal. The Hydrogen Economy and Technology Roadmap, or HETR, aims to produce 16 million tons of hydrogen per year by 2050 to support a sustainable development and energy security. Next, I would like to brief on how hydrogen is produced. The main method of producing hydrogen is steam methane reforming, or also known as SMR. In this process, methane reacts with the steam to produce hydrogen and carbon dioxide. So, to make it more environmental friendly, carbon capture and storage, or CCS, is added to trap the carbon dioxide emissions, which then creates a blue hydrogen. This hydrogen is then purified and used to generate the electricity in proton exchange membrane fuel cells, which produces a clean energy with water as the only byproduct.
Good day, Doctor. I'm Yap Yikan, and I will covering hydrogen power generation technologies and the storage and transport methods because it's crucial for building a hydrogen economy. So first, I will talk about the hydrogen generation power. So one of the way is hydrogen combustion turbines, which generate electricity by burning the hydrogen with air in a combustion chamber. The reaction produces high temperature gases that rotate the turbine with water vapor as the only byproduct. So it's very high efficient. It emits zero carbon dioxide and can be integrated into current gas plants. However, it requires durable materials to withstand the high heat and modification for hydrogen low density. So the next method is the proton exchange membrane, or we can call it as PM fuel cell. It works electrochemically. The hydrogen will split into protons and electrons, then producing electricity, heat, and water. So, by comparing with the two methods, PM fuel cells are more efficient, suitable for smaller, localized systems, but it's more expensive compared to combustion turbines. Due to the many platinum will be used, which is very high cost. Then, for combustion turbines, is suitable for large-scale power and is cheaper, but it have many storage challenge. For Malaysia, PM fuel cells are more aligned with our now current energy goals. Next is the hydrogen storage method. It's a very big challenge due to hydrogen is a very low volume energy density and high flammability. So the most common method is compressed gas method, where the hydrogen is stored in high pressure tanks. It's simple but needs strong materials. Then is liquid hydrogen method, where the hydrogen is cooled to negative 253 almost there degrees Celsius for higher density. However, it's energy intensive and require insulation. And for transport, the first one is pipeline, which is great for large scale continuous delivery, but it's costly to build. Then the next common method is the truck, which is flexible and suitable for short distance. Because the limited capacity of the tank is one of the problem for using this method.
Good morning and good afternoon. I'm Justin, and today I will briefly present on Malaysia's hydrogen power development, focusing on strategic region and key recommendation to address the challenge with the global transition towards a hydrogen company. Malaysia has the opportunity to lead this shift. The first one, I will talk about the strategy region of hydrogen development in Malaysia. In Malaysia, we have two states which is recommended place. First one is Sarawak. Sarawak is the idea of hydrogen, idea for the hydrogen production. Leveraging its abundance hydropower resource like the Bakun and Buran dams. Sarawak Economic Development Corporation is ready partnered with the companies like Petronas to advance hydrogen technologies. Sarawak also the strategic location allow for the hydrogen export, making it a key hub for the Malaysia hydrogen economies. The first place is Sabah. Sabah has a high significant potential due to its solar and wind resources, especially in the region like Kota Marudu. The plans for the 10 GW green hydrogen hubs in Sabah, combined with port access, position is it as an ideal region for hydrogen production and export.
Hello everyone. My name is Rumi, and I will be presenting regarding the why we choose PEMFC technology and how we material selection is done when constructing the PEMFC. So the reasons why we choose PEMFC is because it compared to other method, it tends to be higher. It tends to be highly efficient. It does not release any sort of emissions during use. It is also more tend to be more modular, scalable, and safe. And then it is by using the eco audit function, we found that it's actually more eco-friendly. So modular in this case means because when the PAMC is just arrangement of cells. So if you want to add more capacity, you can just add more cells to your system. So that's why we think it is more modular. So for the material selection process, we found so there's three components. There's the PEM, the membrane, and then there's the anode and the cathode. We compare a multitude of materials by comparing industry standards and also proven technologies. So, but in conclusion, we have found by using the four-stage selection method, we found out the best material for the PEM is PBI, a type of polymer, and then we also found for anode a platinum carbon composite, and for the cathode is platinum graphene composite is best. And the reason is we take account a multitude of critical factors such as high temperature stability, chemical resistance, connectivity, cost efficient, efficiency, and corrosion resistance, and also the impact on the environment. So this is what we think is the best materials to construct the PEMFC cells. So uh, that's all from me. Thank you.
The second one I want to discuss is about the strategy recommendation in Malaysia. In strategy recommendation, we have 5 points. The first one is policy development. Malaysia needs a clear policy framework to encourage investment in hydrogen technology with the incentives for green hydrogen production in infrastructure. Second one is the public engagement. Public education is the key. Awareness campaigns should highlight the benefit and safety of hydrogen to build trust and acceptance. The third one is infrastructure development. Investment in hydrogen infrastructure, including pipelines, storage, and transport network, is essential, especially in strategic regions like Sabah and Sarawak. The fourth is safety and regulator updates. Update safety and regulation for hydrogen and create cross-border trade agreement to facilitate hydrogen export. The last one is research and innovation. Invest in the research to improve hydrogen production technologies, reduce costs and promote regional collaboration to accelerate development. So, in the conclusion, Malaysia is well positioned to become the global leader in the hydrogen economies. Strategic regions like Sabah and Sarawak are the key for this development. By addressing policy gaps, investment in infrastructure, and foster, fostering innovation, Malaysia can transition to a sustainable hydrogen future. Thank you for your attention, and I'm happy to answer any questions.